Another way to look for regularities is by appealing to structural information. Structural information can provide us with new information that cannot be retrieved from the way the information, the, the different uh, patterns um, are followed in our experience. Um, and uh, This structural information cannot be retrieved from the way the conditional probability of given a particular event, which one will follow. We cannot obtain from this sequence of numbers uh, any information that could be very useful to identify some other regularities that occur at other level of resolution. It's easy to see that, for instance, when we have a linguistic sentence in any human natural language, what we see is that words are follow are linearly presented in a way that not only satisfy semantic constraints but also satisfy another the information given by a particular grammar. Uh, for instance, I have no way to identify whether adjectives should follow nouns or adjectives should precede nouns. And this regularity cannot be captured of the information given by the notion of statistical regularity. In fact, we can obtain significant information, we can get significant information by identify the interrelations or interconnection which events or entities enter into. So the question that, for instance, in the case of language, the words themselves enter in different relationships, in different kind what we call this dependent relationships, dependency relationships, and this interconnection among features yield important structural information which facilitates structural description or classification. The notion behind this regularity is the notion of a formal rule. The system should be able to quantify and extract structural information and to assess structural similarity of patterns. A syntactic approach has to relate the structure of patterns with the syntax of a formally defined language. This is the case of sentence generation and sentence parsing. And the primitive elements or the building blocks are extracted for the input data, but the primitives are composed in more complex classes, and those classes are relevant for defining a structural relationship uh, between them. So this is the case, for instance, that happens in language, but also happens in music. In the case of music, we find that musical patterns are a very good example of structural information. Same elemental features, um, a series of distinct tones, 72 tones, uh, are used according to six octaves, and all the music is made of these 72 distinct tones. Uh, the music musical melodies differ each other in the temporal arrangement and the structure of these notes, and the way these notes are structured in the partiture defines the music. So the information that can be extracted from and the way events or entities are structurally interconnected is the kind of information that can be exploited to recognize structural regularities. And those structural regularities cannot be retrieved from the information provided by the notion of distribution, the way events or entities are distributed across time. We have a very interesting sample in this slide in which we present the way we can relate information, distributional information with structural information. In the case of electrocardiogram, we see a waveform function, and the shape of this wave provides us with information about an underlying mechanism. Okay, what we do when we try to identify the components of this waveform, we are able to understand that any impulse is related to the particular way the heart is working in the human body. So by establishing relationships between different segments of this signal, we can retrieve information about whether the heart is working correctly. So in the case we don't in the case that we don't find any particular illness, okay, and this structural information is got from the fact that the waveform is related to mechanisms that can be independently analyzed. So structural information give us the opportunity to find structural regularities, and those structural regularities is what we are calling syntactic regularities, regularities that are given by the way things work. Finally, we have a different kind of regularity. And this regularity can be called neural pattern recognition, or maybe you can use semantic regularities. Sometimes the regularity underlying a particular series of continuous phenomena is an associative link. So there is no specific information that can be given just to recognize that two different patterns follow according to a particular property. So when we talk about association, any pattern can be associated with anyone. There is no in no way we can find any interrelationship that we could exploit to define whether these two patterns are linked according to a particular rule or according to a particular distribution. What happens, in fact, is that every word can be related to any other according to its semantic content. And because of this semantic content, with these two words appear together in a particular sentence. So what happens between the word doctor and the word nurse is a kind of a kind of associative link. It's a kind of it's a kind of semantic connection. Is, let's say, is a kind of content based association. Okay, there is nothing. There is nothing in the word nurse and the word doctor that put together these two words in a particular link. So when we perceive a link between semantically between nurses and doctors, what we are saying is that we have experienced before this connection in our experience, and of course, this any semantic relationship comes from our our experience and the way we use language. But in fact, both words has no connection for anyone who don't know what is meant by a nurse, by the word nurse and by the word doctor. So we can talk in here about associative content, and the associative content is meaning. Well, the problem is that when we observe semantic generalization, what we are mm, mm, what we have is a kind of associative relationship, and this associative relationship cannot be captured by uh, statistical pattern recognition or structural pattern recognition. So we have to appeal to another kind of underlying mechanisms, and those mechanisms are what we are usually calling meaning. The meaning account for the connection between these particular words, nurses and doctors. Uh, well, how could we capture this process? How could we capture in which way two events or an event or an entity or two entities are connected? Okay, of course we have to appeal to learning. And the way we have to talk about learning is by appealing to the way our neural networks learn to connect different experiences. And this is the reason for introducing here the notion of a neural network. A neural network defines a computational information processing system which may compute any function, linear, quasi-linear, or nonlinear functions, and the kind of work that a neural network does is a work that cannot be entirely reproduced by an algorithm because neural networks use information, uh, uh, associate patterns just by determining the predicted value of a particular event as a prime of other uh, events. An artificial neural network is characterized by three traits. One is the topology of the network, that is the connection, the interconnections that exist among neural units. and also the characteristics of the individual units. And finally, the third stage of the neural network is the way the particular neural network is able to learn.